Okay, number 3, the diagram on the right shows the straight line CD which is 6 centimeter long. T is a point that is always 1.5 centimeter from the straight line CD. Okay, 1.5. Draw the locus of point T. Yeah, I believe you can guess where the locus shall be. It will be 2 locus, correct? If given one fixed line, we're going to have locus number 1 up there, and we're going to have a locus number 2 down there. Then B, describe completely the locus of point T. Describe completely, draw the locus, describe completely the locus of point T. Okay, to describe is to mention this condition, that is always 1.5 centimeter from the straight line, up and below and above. Okay, 4, construct the locus of point Y for a given situation. Situation number 1, it is equidistant from the straight line PQ and PR. So you do the perpendicular bisector. Okay, you do the bisector. You do the bisector using a compass. For this, YC equal to YD. YC equal to YD. YC, point Y to C equal to point Y to D. So the idea is it's going to be in a middle, right in the middle, like that. So this is point Y. Okay, and this Y can move all the way straight line here, because it will still preserve the condition, which is YC equal to YD, equidistant. So if you connect all these points, you will have the straight line. Okay, use a compass to have the straight line perpendicular bisector to this line CD, and then angle PQY equal to angle Y is where the angle PQY equal to angle RQY. So if we take one example, let's say 1 point. Okay, let's say Y is there, which divide by this angle here PQR, the same as angle RQY. So the idea is you're going to have also many points here, and if you connect all the points, you will have the line divide equidistant, divide the angle in equal size. Okay, in order to do that, also you're going to need a compass. Okay, construct a intersection arcs which can bisect this PQR with the same angle. 5, the picture on the right shows a running track. An athlete always practice by running 2 lanes away from lane 4. 2 lanes away from lane 4 of the track. Draw the locus of the athlete's run. 2 lanes away from lane 4. Here it is, lane 4. So it is like all of this lane here, all of this lane here, as I put a shade on it, okay, it's a line, one single line. So the idea is 2 lanes away, the condition 2 lanes, 1, 2, 2 lanes, 3, it's going to be on lane number 3 here, which is 2 lanes away, and so thus on the right side here, okay, still fulfill the condition 2 lanes away. So here is similar to this, similar to this. We're going to have a locus up there and below, which is 2 lanes away. Okay. So back to the first concept. If given to us one fixed line, we will have 2 locus up and down, or left to right, left and right. Okay, that is the idea. Moving along, how do you determine the locus that satisfy 2 or more conditions? How do you determine the locus that satisfy 2 or more conditions? 2 or more, what does that mean? They they combine the condition? Okay, let's try the question. Example 11, the grid on the right shows a square ABCD. Here it is, drawn on a square grid with sides of 1 unit. Points X and Y are 2 points. Points X and Y are 2 points, okay, that move inside the square ABCD on the grid. Okay, on the grid. Number 1, A, draw the locus of a moving point X, which is constantly 7 units from A. So we take one box as 1 unit. So where is it? Point A. Here it is, point A. So this point X here must be always 7 units from this point A here. Okay, let's take one example. In horizontal line here, let's have 7 units from A. So 1, 2, 3, 4, 5, 6, 7. So one example of 1 point which is 7 units away from A is this. So X can be here, point X can be here. Okay, if you find on this vertical line here, we're going to count up to 7 to 1, 2, 3, 4, 5, 6, 7. So here it is, another point that X can be. Stay away 7 units from point A. Okay. But you know what? This X, it can move. It can move freely as long as it fulfills the condition, that is, it must away from point A 7 units. So in this to this space here, we don't know where to mark the point, since the point is not going to be right on the the vertex of the box here. Okay, but we got the idea. The idea is somehow we can predict it going to be in a curve, which is always 7 units. Okay, from point A. So the idea is this A here is like what? It's like a center for the circle. If you notice, if we have this circle which passing through this point here, so we're going to have something like this, the circle like this. Okay, which coming from this center A. So the idea is to find the locus of this X. We construct the circle lah. Okay, we construct the circle. Okay, because we need to find the locus inside this big box here, this grid here, is why we just need to construct a quarter of the circle. The circle, only a part of circle which we can only have inside this box here. So here it is. How do we supposed to find the locus, trace the locus, draw the locus of X? Okay, here I stick the needle on a point A as a center, and the other end is, which expand this compass to 7 unit. See, I make this pencil here, tip of the pencil really up upon the point of X to measure 7 centimeter. So now we rotate. Why not same? Here supposed to meet this circle, supposed to meet at this point X. But you know what? This is the error of the print. Once they print this textbook, the print doesn't follow the actual length. So this is why we the circle not meet right on the point here. But at least you got the right idea. Okay, it's just a matter of the print is not printed in actual size. So there it is. Let's just assume that this circle meet this point X here. So you see, actually this 7 unit is a radius, which preserve the length, whatever the length that they want. In this case, 7 unit. Okay, the radius is 7. So here is where you will get the locus. B, draw the locus of a moving point Y, which is equidistant from the lines AB and CD. Lines. Okay, so you notice lines. First we need to determine those 2 lines here, AB and CD. So where is line AB? Here it is. We got AB here. And where is line CD? Here it is, CD. Okay, up and under, okay, up and below. So we need to find the point Y, which is equidistant between these 2 lines here. in order for you to not get confused, I need to erase this. So it will be a new space for a new question. So now this grid now is ready for the new question. Okay, as usual, before we find the locus, we need to ensure where is the line that we refer to by darken the line. Okay, darken the line like this, below and above. And then we're going to construct. Before we're able to do that, let's have some one point, at least two points of point y, which is can divide equidistant, the length, which is the, let's say from this point A to D, if you're going to be in the middle, where you're going to stand, where you're going to be. Is it here? Because we have 1, 2, 3, 4 box up there and 4 box down there. So this point here is in a middle. Now we're going to need another one point in the middle. Let's take this end here, B to C. In the middle is there. So now we got a pretty idea where is the locus going to be. It is in the middle. There it is, the locus that we need to find. So if you notice, back to the first concept that we learned, if given to us two fixed line, and then we required to find the locus, absolutely we're going to find the locus, only one locus right in the middle of those two fixed line. That's the idea. No matter how many question that you do, is what you're going to only approve the concept that we just learned. Okay. C. Mark all points of intersection Oh yeah, before that, before I forgot things, we need to take your attendant, you need to take your attendant to record in a system, online system. So let me check. To ensure that it is not the the robot of you, only your icon come in here, but the actual you. So I need you to take type your name. Type your name on in call message right now. Shall we give a couple minutes to settle your attendant? Okay, keep going, come on. I need to record. We need to record. All of us need to record the attendant. Okay, come on. Only 3. What happened to other? Come on. It shouldn't take long. Huh? Come on, come on, come on. Madiha, Haida, Afifa already. Where are the other? Come on. Okay, Tika, good. Go, go, go. Keep moving, keep moving. It is not hard to type your name, even you use your mobile phone. Only a short name. Okay, this telling me that you really actually exist in this virtual world. Okay, keep moving, keep moving. We got so many questions need to be done in this lesson, so it won't bother us to move to next chapter. So come on. I'm not sure what took you the others so long to write their name. Okay, meanwhile, let's continue our journey. So where is it? C. Mark all points of intersection of locus of X and locus of Y with the symbol this. Okay, with this symbol. So before we able to find the intersection, first we have to find the locus of X, and then followed by find the locus of Y. Okay, shall we? X and Y. But oh yeah, they refer to in this case we X is such as in question A, and Y is in question B. So this time they want to combine all the locus. Remember that the first one we find the what, a part of the circle, which is 7 units. Okay, 7 units away from the center, like this. We have to redraw back like this. Okay, this is the locus from question A, and this is the locus from question B. And question C, they ask to put a mark on the intersection between those locus. This locus and this locus, where do they intercept? Where do they intercept? It is clearly, we can see it is here. Okay, is where the locus intercepted. So yeah, how do we put the mark as they need? Is like this. We're going to put this mark here, circle and X mark. Okay, X mark in the circle. So here it is. How to answer question C. Oh, here we got the solution. Okay, simple. Simple pimple. Simple pimple. Moving along, question example 12. The diagram on the right shows 4 combined squares with sides of 2 centimeter. So yeah, correct, we have four of this square combined, okay, which is the length of one square box here, P to Q, is 2 centimeter, horizontal and vertical, 2 centimeter. X and Y are two moving points inside the square PRTV. Inside PRTV. So there will be 2 points X and Y which are moving inside this combined box here, combined square box. Okay, on the diagram, A, draw the locus of a moving point X, which is always 2 centimeter from point M. Where is it, point M? Here it is, in the middle. Okay, and point X shall be always 2 centimeter from this point M, 2 centimeter. So let's find some of the point X where it is possible to be. One of them is Q, at Q, correct? Because this point at Q here to M is 2 centimeter. Okay, and so this S here 2 centimeter, and so does U here, and so does W. Okay, not only that, if the point also can be right in the inside box here, somewhere like that. Okay, we can imagine it to be there. Okay, but as long as it preserve this 2 centimeter, okay, it is okay to be anywhere that it want the log. So we see, if we kind of trace all the points here, doesn't it resemble something? If we try to connect all the points here, what does the shape does it look like?
Diamond. Square.
Diamond. Square? No, a circle. A circle which is 2 centimeter always. Remember that one? You know what? Let's get back to the first concept that we learned. If we given only one point, okay, only one fixed point, if we want to find the locus, what is the shape that we will going to have?
Circle.
Circle. Where is it? So here it is. Remember that one? Given only one point, then given some condition, that point must be 5, let's say some distance from this fixed point, while it can move. So where do you going to move as long as it preserve this 5 centimeter? Guess what?
Circle.
At last you're going to have many points, okay, which is 5 centimeter, and if you connect all of them, is what make a circle. Okay, so that's this. So that is the idea. So you see, the more question that we do, the more exercise we do, not but only a proof but only a proof to us, make us convinced that the concept that we just learned at previous lesson. So that's this case here, because we need to find the locus of this only one fixed point here. This is why we get the idea the locus going to be circle, because the only circle shape that can preserve the whatever the condition is. Okay, so this 2 centimeter here is like we're having a radius, of a circle. So here it is, a radius of 2 centimeter. At last we constructed the circle. Okay, so we done question A. Let's move to B. Draw the locus of a moving point Y, which is equidistant from line PR and line PV. Do I have to mention to you again and again the same concept? Should come to sense now. Okay, all the concept is keep repeating the same concept again and again, no matter how many questions that we face. Okay, line, this time we have two line, two fixed line, PR and PV, that we need to determine before we find the locus. Here it is, PR, and here it is, PV, vertical, horizontal here. So to have a better work later, this is when we darken the line. Okay, so how to find this point Y, which is equidistant from these two lines? First, at least we're going to need what? To need at least 1 point. Okay, 1 point of the locus, and it is going to be pointy here, correct? Pointy here is one of the point on the locus, which is equidistant from those two fixed lines. Okay, we need nothing more because actually we already for this intersecting line, we actually already got point number 1. It is right where they intersect each other. Okay, at point P here. The only thing that we need is another point. But by compare this square here is what makes us able to predict where that this point of T is, which divide the same angle. So if we construct a line, is what we construct the locus that we need to find. So here it is, the locus. Okay. Question C, mark all points of intersection of locus of X and locus of Y with this symbol. Okay, whatever the intersection that happened between locus X and Y. So here it is. We found number 1, where the locus the locuses intersect each other. Okay, so we're going to mark the symbol. Do we have another one? Is at this point, correct? At this point.
Correct.
So there it is. We got 2 marks. Okay. Oh, so they have the solution for these 2, huh? Okay. Wow, we got so many. Okay, keep moving. My test 8.2b. In the grid on the right, the rectangle ABCD represents a part of a lake. Part of a lake. Mana Haziq? Haziq tak tanda lagi. Haziq. Lepas tu siapa lagi 8? Dia sudah Edina. Siapa lagi ni? Belum tanda ni. Syamimi dah lah tanda. Isra. Syaza. Hai, peranti apa kamu pakai ni? Tak ada keyboard kot. Syamimi tak tanda lagi. Syamimi. Isra.
Macam Mimi line dia slow cikgu.
Tapi cuma masukkan apa? Nama saja. Takkan line slow tak dapat buat. Isra macam mana? Isra pun line slow juga. Tak nama je pun. Okay, continue. In the grid on the right, the rectangle ABCD represents a part of a lake. ABCD is drawn on a square grid with sides of 1 unit. Points V and W represent the trips of both V and both W. On the grid A, draw the locus of both V, which is always moves 5 units from point D. So where is it, point D? Here it is. Always 5 units. Remember, if you notice, we got 1 point and then we ask to find the locus, correct? So can you quickly guess what is the shape going to look like if we construct the locus from 1 fixed point here? Remember, the same the what it is, the shape of the circle right? Okay, since we need to find the locus inside this box only, this is when we will have a partial only, a quarter of the circle. So 5 unit is, first let's have some point to begin with. 1, 2, 3, 4, 5. So here is one of the point on the locus. Now by refer to this point here, we can set the compass to have 5 unit always. Have 5 unit always rotate from the center D. So here it is. Okay, got no problem. Let it be there,
Yes.
because at last they're going to find the ask us to find the intersection. Cannot erase that. B, draw the locus of both W, which is 3 units, from line BC. Oh, this time only one fixed line, and you're supposed to have the quick idea what this locus going to look like from this only one fixed line. That is, we're going to have 2, correct? How many locus? How many locus that we're going to have? 2 locus out of one fixed point. You're supposed to be able to imagine like that before you come to show the work. Okay. A good prediction is what make your work more easier to find to do. So where is this line BC? It is on this side, BC. Okay. So the 2 locus is going to be on the left side and right side, because this right side is off from this grid. Okay, not in this grid. Is what we're going to have only one side, that is on the left. Okay, which is 3 unit. Let's say we take this point B here, okay, as a point of reference. Then we're going to count to 3 units. So the point going to be there, point of W. Okay, and from this point C here as a reference, also we're going to count to 3, 1, 2, 3 units, and the point of W going to be there. So at least we got 2 points. We can have the locus by construct a line passing through these 2 points that we figure out. So here it is. Okay, they intersect. The locus number 1 intersect the locus number 2 at this point. As you can see, mark the intersection of the path of both V and both W with the symbol this. Okay, not a big problem. Okay, so here it is. How do we put the mark as they required? Easy, easy peasy. Number 2. The diagram on the right shows the Cartesian plane. Mark Cartesian plane is we got 2 axis y and axis x. That's what we call Cartesian plane. Okay. Mark with 4 points: E, F, G, H. E, F, G, H. Okay. Furrow is at the same distance from x axis and y axis is at the same distance. So here it is y axis, here it is x axis. Furrow is at the same distance. Do you remember this? Do you remember this? 2 intersection line here. We did this, right? We did this concept. So if you're going to be in a middle between this perpendicular bisector 2 line here, where are you going to be?
G.
Yes, one of
G.
them if is G. So here it is. That's what we learn. We have these 2 lines here which is perpendicular to each other. So if you're going to be in a middle, you're going to be there, Okay, there. If you connect all of them, it's what make the locus look like, which divide two lines with the same length, the same angle, the same length. So the same idea here, okay, apply the same idea here. We're going to find the to do the bisect, to divide. So you know what, this time we don't use compass. Why? Because we assisted by
Tidak
this
apa.
grid line. We can have this grid to help us to divide, to bisect to two same angle. Okay, here it is. So you see, whatever the point is on the line, the locus line that we just constructed, is the point where the furrow possible to be. Okay, so furrow either can be at this point G or this point F. Okay, you got the idea. Furrow's location is also less than 5 units from the center of O. Here it is, the center, and furrow O. Now this is another condition.
G.
Another condition. The second condition. Because if we choose F, furrow cannot be there because it is more than 5 units. Okay, so the possible place location that he can be is only at G, which fulfill both conditions. Okay, that is at point G. Which of the points E, F, G, and H is furrow's location? Okay, point G. And that is how to answer this question. Any question until now? No. Okay, we got question 3. The diagram on the right. When do we finish? What time?
10.40.
Okay, 10:40. Moving along. Hope that we can finish all this. This question in this topic. 3. The diagram on the right shows the Cartesian plane. Point F always move 3 units from the x-axis. 3 units. Okay. I'm not going to go detail. You know the process already. X-axis is here. 3 units. 3 units is 1, 2, 3. Here it is. 3 units. Okay, this is locus F. While point G always move 4 units from the origin. Here it is, the origin. Means that we got only one fixed point. And the same, I don't need to remind you again and again what locus shape that we can have from only one fixed point. It is the circle, correct? The circle, 4 units. So quickly you're going to place your compass 4 centimeter. For what? 4 units. 4 units and not 4 centimeter. So here it is, 4 units, 4 boxes. This text box print is not the actual size. Okay, it's supposed to intercept these two here, but it doesn't because something wrong with the print. Never mind that, but you got the idea. Mark all the points of intersection between the locus of F and the locus of G with this symbol. So here it is, where those two lines, two locus meet. Okay, simple, simple pimple, just like that. How do you solve problem involving loci? Example 13, a clinic will be built in a village. The clinic should be equidistant from house P and house Q, equidistant, as well as 600 meters away from, this is going to be next condition, 600 meters away from the highway AB. Okay, I think I got enough information to imagine things. How about you? Can you imagine this? Determine the possible location of the clinic. Okay, we take that 1 centimeter is 600 meters. Okay, not bad. Now first let's find the locus.
Cikgu,
Ya.
boleh agak-agak je 600 meter tu panjang mana?
Mana boleh, sebab dia sudah bagi tepat sini. Maknanya kita kena guna pembaris 1 cm. Okay, kita kena tandakan, kena ukur 1 cm daripada jalan ni. Itulah dia, di mana 600 meter di atas peta yang sebenar. Okay, ini kamu belajar geografi. Memang geografi pun sama kan, kita ada peta, kita ada scale ni. Okay, scale ini 1 cm here is a scale on a paper, correct? Because we cannot have this way too huge length on just a small piece of paper, you know. Okay, this is when we need to use the ratio of the scale. Now again, we going to back to the case. Let's find the locus where divided these two fixed points here, PQ, with the same equidistant, with same equidistant length. Yeah, I know. You know, I don't need to remind you again and again. What will you do if you need to find the locus from these 2 points here? Okay, back to the same concept lah. If given to us 2 fixed points, then what? Then you need to find the locus. You're going to construct line perpendicular to those fixed points. Okay, it is like you need to find the line perpendicular to these both points, given points. We're going to apply this to this. In order to do that, we need a compass. Okay, now let's do the. Okay, if you assume where the point going to be in a middle P and Q, so you try to fill it and you kind of put a mark there. You feel it going to be in the middle there, and we go up there also the same. You're going to, as long as it divide by 2 same length, you're going to be there, and go up more, up there, and you go below also the same, as long as you be fair between 2. Okay, so the these points here give you the idea. Okay, these several points here give you the idea of what the locus may look like. So to find the actual locus, okay, the accurate one is when you need the compass. Okay, now construct up and below two intersection arcs. Okay, so we will have 2 points, up and below, before we construct a line. And that line absolutely going to divide the points, the fixed point, to two same equidistant. Like that. So here it is, the line that the line here in the middle is locus. So this line here is only condition number 1. Now we have condition number 2 that we need to obey. That is, the clinic is 600 meters away from the highway AB. Here it is, we have highway AB. Okay, so it must be 600 meter away. 600 meter is 1 centimeter scale on a paper. So it is like we measure like this. So from this point to 1 centimeter. Okay, so here it is. The clinic supposed to be. But you know what? This is wrong. This is wrong. Why? Here to here is not 600 meter. It is less. Why? Because we need to find 600 meter from the closest point on this line AB. So because you see this line here, the locus is not perpendicular to this line. So actually we don't have 600 meter here, but less than that. Why? Because from this point, if we construct the perpendicular line, okay, so you see it's going to be less than 600 meter. So this is not the correct way to mark 600 meter. Okay, in order to find the accurate 600 meter, we need to find the line which is 600 meter away from this line. It is like we have to find the locus for this fixed line here, okay, AB, as usual. So this is when you need to place your ruler on this point A here, and then what? You're going to put a mark 1 centimeter. Make sure your ruler is straight. So there it is. One centimeter. Okay, 1 centimeter. And if we need another point, okay, we need another point to, at least we need 2 points lah before we construct a line, correct? So here it is. I'm going to make sure this ruler here you place perpendicular to this line. So here it is, point number 2. Now connect both points, and you will have the locus, which is away from this line AB 600 meters. Okay, this is when you find this locus here, which intercept this locus. The first one is where the clinic shall be. It is right there. Okay, right there. Now, any question? Do you clear about this? You okay?
Yes.
Okay. Does somebody faint learning this topic? Okay. Okay. So you see they construct 600 meter, which is 1 centimeter. Okay. Not we measure from this point to this point 1 centimeter. It's very wrong. Okay, so the height is 1 centimeter, perpendicular line. Oh yeah, wait a minute. I forgot. Do you notice something? Actually, we can have two location of clinic up there, okay, and below, because this line here is what result these two locus, up and down. Okay, so the same, we're going to have the locus under 1 centimeter. Okay, 1 centimeter, 1 centimeter, and then you're going to construct the locus. Okay, wherever this locus meet this locus is where the clinic can be. Okay, another location that it can be, which fulfill those two conditions. Okay, that is the idea. So you see this locus is really what, really helpful when you do the math things. Okay, when your job is maybe geographer, the person who involved in geographic things, is it what we call geographer? I don't know what do they call. Mind test 8.2c. The diagram on the right shows square PQRS with sides of 6 centimeter. Okay, two semicircle with center M and N are drawn inside square PQRS. M and N are the midpoints of PS. Midpoint of PS and QR. PS and QR, midpoint. Okay, correct. On the diagram, shade the region that satisfy the following conditions. A, the locus of point X, which moves such that XM, okay, XM be equal or lower than 3 centimeter. Here it is M, 3 centimeter. Okay, this M to this semicircle here is 3 centimeter, correct? So if we want to find the locus of point X more than 3 centimeter from line SR, the locus of such that X to M 3 centimeter, okay, really up on this curved line here, the semicircle here, and we got another condition, and more than 3 centimeter from line SR. Where is it? Line SR. More than 3 centimeter. Oh, okay, so here it is, MN. MN is the line which is 3 centimeter away from SR. So the locus of point X going to be, shade the region that satisfy, going to be this. Tell me if I'm wrong. Is this correct? Where I shaded it? Okay. Number one, the condition number one, below this 3 centimeter from M. Condition number two, up, above, more than this 3 centimeter from this SR. So the area that left is where I put the shade on it. Can you imagine that? Okay. B, the locus of Y which moves such that YM equal or more than 3 centimeter. 3 centimeter. So M here, more than 3 centimeter. So inside, in this box, except this area, POS, except this area, is where the locus of Y. And then another condition, YN, the locus of YN more equal or more than 3 centimeter. Where is N? Here it is. Okay. N to this O is 3 centimeter, and also Q and R means that whatever that left inside the box, we minus this circle here, circle space here, semicircle here, and also we minus this, we throw out this semicircle here space, and that the space that is left is this, okay, this space. So this is when we put the shaded, put the shade, okay, like that. C, describe the intersection between locus of X and locus of Y. Okay, intersection, the intersection between locus of X and locus of Y. Do they intersect? At which space? I cannot find where do they intersect. Do we have a answer for this? Mind test 8.2c. 8.2c. Okay, as we did, okay. See, the intersection between the locus of x and locus of y is arc OP. Oh, okay. Oh, so we mentioned where the boundaries is. The boundaries, boundaries, where both different shaded meet. Okay, we mentioned the boundaries. That is arc OP. As simple as that. Okay. Number 2, the diagram on the right shows a rectangular fence up grass field PQRS measuring 6 meter, 8 meter. A goat is tied at point Q with a 7 meter long rope. Okay, shade the region that is reachable by the goat. Also, you're going to see this as you see the concept. We given only one point, one fixed point Q here. Okay, how does this, given a condition that it can move only 7 meter from this fixed point, okay, so what is the locus of this goat here can move away 7 centimeter from point Q. Okay, you know that the locus, the shape of the locus from a fixed point, it's going to be a circle, correct? So 7 centimeter. Here we have 8 centimeter, 7 centimeter. Is it the measure follow the actual length 8 centimeter? No. On our book it is only 5 something centimeter. So we just need to estimate. So make sure you estimate logically. 8 meter here. Okay, 7 shall be around that. Make it a little less there. So if you construct the locus, it's going to look like this only. So this is, oh wait, here is 6 centimeter. So we need to adjust this so it reach more than 6 centimeter and it below than 8 centimeter. Okay, more than 6 centimeter, something like that lah. Okay, there it is, the radius that on the goat only can move far away from the point. Now do you see this? Okay, is it correct? Okay, correct. It's going to look like this. Okay, 7 centimeter. Okay, so the area is where the goat can go all around, as long as the goat cannot reach more than 7 meter. Okay, any question? How about I leave this, the rest of the question to you, as a offline learning. Shall we? Shall we? Okay, I leave the rest to you lah. Okay. Is this the only who attend here? The one who gave the name Madihah, Aida, Afifah, Atikah, Zulhaziq, Idridina, Jannah, Aini, Hanis, Haziq. We only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10. Only 10%. Is it correct? How about Isra? Isra. Shamimi? We got a problem to type. Siapa lagi? Jannah dah. Sudah. Ish, macam mana ni? Jadi Syamimi betul-betul hadir ke dok ni? Syamimi dengan siapa ni? Isra ada Isra. Kalau line slow macam mana boleh masuk ah? You cannot even enter this Google Meet if you got weak signal ah. If you able to reach this to enter this Google Meet, means that you are more able to type your name. That only take a little byte only, a small byte of internet, of data and speed. Okay, you can do big thing, why you cannot do small thing? It's what made me wonder. Syamimi, say something lah. Even you don't want to type your name. Syamimi, come on. Macam mana Syamimi boleh ada dalam ni tapi no respond lah. Syamimi, siapa lagi ni? Isra. Oh, Isra. Ya ampun. Dia punya komputer saja hadir lah. Di actual Isra ni hadir ke tak ni? Isra. Cikgu kira tak hadir ni. Kalau tak jawab ni. Isra dengan Syamimi. Mana nak buat?